Thank you, Roger, very, very much. It's a little overwhelming to have people like Ed and Isla, who I respect so much, to invite me to be here tonight, and what an amazing conference. It's been so clear from the response of everyone that I've spoken to since I got here, what a great few days it's been. Also, thanks to Donna Robertson and everyone at ACSA. It's really fun to be here and to share the ideas and some of the things that have been going on at SHOP for the last few years, and to think about how we've tried to lead a little bit by example, and we've tried to challenge the way that we practice as a profession, and it all comes out of loving being an architect. So SHOP, as Ed, this thing is really loud. Am I screaming? Yeah. Can we turn it down a little bit? And one other thing I'm going to ask for before I start. Is there any water anywhere? Can someone get that? Okay, thanks. So SHOP, as Ed said, is an acronym that originally came from the last names of the partners of the founders, which are Sharpless, Holden, Pasquarelli. But very early on in the process, we actually took our names off the firm, and that we felt that we wanted to be something that was beyond the 5 of us, now the 7 of us, now the 100+ of us, and that it was something that was about a new kind of firm, a think tank, a workshop, a place that didn't only have to practice architecture in the traditional way, but was willing to take all the things that we think are so incredibly wonderful about our profession and take all the kind of intelligence and sort of inspiration and creativity that surrounds an architecture firm and push the way that we could practice. So again, there are 3 names, but there were 5 original partners, and that's because the partnership is made up of 2 married couples and the identical twin brother of one of the husbands. So that confuses everybody, including our clients. So we made this chart, thank you very much, to sort of explain it. So basically, this is the year that we graduated from Columbia. Chris was in 90, we were all in 94. If you're inside the green box, you're married and you share things like bank accounts. And if you're inside the blue ellipse, you're identical twins and share things like genetic code. Bill and I were the housing studio at Columbia is sort of the first time you work with somebody, and that was really the kind of genesis of the firm in the beginning. But I think that one thing that's of interest in this slide is that you'll see there are other professions underneath each one of our names, and that's because we all kind of had other careers before we came to architecture. And not that that's a good thing or a bad thing, but I think that it did allow us to sort of freely adapt other methods of problem solving and to try and bring these other ideas into the architecture profession. Among the people, well, that's very clear, you can read that right there. But among the people that are part of SHOP, we also love to have people who have had multiple careers and have had different kinds of training and are willing to think in multiple ways. In 2007, we formed SHOP Construction, which I'll talk a little bit more about, and John became the 6th partner running that practice. That sort of has taken a lot of the things that SHOP had developed over the previous decade and spun it off into a separate consulting company that sort of helps not only SHOP build buildings, but other architects build buildings, and also to work with other major contractors to figure out how to make very complex structures at reasonable cost. And then last year, we added the 7th partner, Vishan Chakrabarty. For me, it was, I finally found my other twin, which is clear because both of our names have 11 letters in them that end in I. So, I think that when we were in school, and things have changed a little bit, but it's still there, and this idea, this is sort of the history of architectural practice in the last 150 years summarized in one slide. And the thing that sort of got to us a little bit was when we were in school, our professors, who were amazing. Columbia was an incredible place to go to school. We all feel really fortunate to be there in the early 90s and to teach there for a decade after. But there was really like questions. People would actually say hey, you guys are really good designers. So are you gonna do competitions and make cool buildings? Or are you gonna go work for a firm and figure out how to put buildings together? And that was a little bit shocking to us, that we didn't realize that, we didn't understand why that choice had to be there. And it really, from day one for us, was about bringing these things together. I think at the same time we had a little bit of a criticism in the sort of cycle of stylistic consumption or this kind of idea that something would be written, there'd be text that are written and theory text, and then suddenly it would be adapted to a form, and then it would kind of get a show at MoMA, and then 3 of the buildings would get built, and then it would be derided, and the next one would come. And we just really always thought about architecture as a much longer term game. And so I think from day one, it was always about this idea of being, slightly tongue-in-cheek, both and firm. This idea that teaching and theory and being a kind of guardian of culture is unbelievably important. But that did not mean that we had to give up the ability to understand how buildings could go together, to really work at a kind of large city scale about detail, fabrication, manufacturing, politics, finance, and work at that other scale simultaneously. So, the idea, if we weren't going to have, we didn't really come together because we had a shared aesthetic. We came together more because we had this, and I don't want to say criticism, it's not the right word, but this desire to see what the profession could be in a slightly different way. And this notion of performance-based design was something that we kept talking about, that instead of it being a kind of aesthetic that you could attach to the buildings or the way in which one would design, it was really about how the buildings worked, how they were put together, what they did culturally, how they occupied their site. And if we could begin to start to develop a methodology for that the shapes and forms would begin to emerge themselves. So, we looked at aerospace, we looked at automotive, we looked at nature. We looked into history. We looked at, right about this time, the computers are sort of this is the mid to late 90s, the computers are getting fast enough and cheap enough that architects could afford them, quite frankly. And a lot of the sort of performance values that we were putting into these things as we were trying to negotiate what the buildings were supposed to do were giving us complex forms. Now, we looked at the history of complex form, and, obviously there's a long one in architecture, but it was always one that sort of relied on labor to execute it. And obviously we were not going to be able to afford to do that at this juncture. So we continued to look through history, to look at every time there were sort of technological changes, material changes, and the way that those ideas about materials, shape, form, execution, like ornament, came together, and that paradigm shifts would occur every time these kind of new materials emerged. But also, simultaneously, if you want to get it built, and we were always extremely committed to, I have to say it's the first time I've ever been blinded by the sun in a lecture. Is this why you come to California? Is this what you're doing to me? Do I need suntan lotion? All right. You're just lucky I'm not in my bathing suit. So basically, at the same time, we were interested in these kinds of forms, but it always came back to us for how to produce them, how to make them, that they would have this kind of effect in the city. But if we didn't know, if we were just going to make images to hand off to other people to build, we just felt they wouldn't get built. And so we wanted to be sort of equally connected to all of those modes of production. Now, the more that we investigated this stuff, the thing that became very apparent to us early on was that the sort of standard convention of drawing, of plan, section, and elevation started to become less and less relevant, and that doing this kind of abstract language, and because look, at the end of the day, as architects, that's what we do. We don't really build buildings. We make instruction sets for other people to build buildings. And if we were going to sort of use this shifting paradigm, this moment where the technology was changing things, if we were going to try and push the notion of performance-based design and the way in which that connects to a city and has certain effects, and we wanted to get these buildings built, we had to start thinking about other kinds of drawings. And it just emerged naturally in the office as we were working through these things to think about what those would be. And it started to become drawings that were more about instructions for making things, but about time, about weights, about shipping, about how to put forms together in a way that simplified it so that you could get, sort of by simplifying the instructions, we felt we could get the most complicated buildings on the other side, a kind of equal and opposite reaction. So how to go about it? We're just a young practice, and there's 5 of us in a loft, basically above a Chinese restaurant. You had to cut through the back of the kitchen of the Chinese restaurant to get up to our space. And we were sitting around, and one of the things we thought about was this drawing. So we would make an argument that this is the single worst drawing in the history of architecture. And that at the end of the day, we do not believe this is a drawing made by architects. This is a drawing that's made by lawyers who want to ensure that they have work for the rest of their lives. This is a drawing that sets up an acrimonious relationship between the 3 major players of who actually makes space. And so I think that we probably didn't understand it right at that time, but a lot of what we've tried to do is really kind of attack this drawing by taking on different risks, by grabbing back different territories, by exploring the different ways that architects could be involved to try and change this drawing into a new method of practice. So very simply in the beginning, there was a notion of including consultants from day one. Now, I don't mean like you sit down with your mechanical or structural engineer. I mean, I think the way that we started thinking about it was the fact that, if we were going to, for example, if we were going to do a metal building, do you draw up a metal building, or do you meet with the guys that actually produce the metal on day one? Do you find out what are the 8 different ways that you can fold and clip metal? Do you find out how big the coils are that it comes in? Do you find out how it gets picked up off a truck? Do you figure out what are the ways they like doing things and what are the ways they don't like doing things? And we literally have those conversations before any drawing ever happens on any of our buildings. So immediately there's an idea about what we want to do. We think about a material and a system and a way that we might want to attack it. And literally that becomes one of the parameters, one of the drivers of the design itself. It's starting to calm down. So, from very early work, like our competition, our entry that we did for the Young Architects Prize at PS1, where the program, like thinking about the notion of performance-based design and thinking about how you make it. So the program was an urban beach, and we just very simply, this was the drawing that we did for the competition. We said, well, performatively, what do you need in order to make an urban beach? We said, if you have a shading device, an area to change, an area to sit, an area to dance, and an area to get wet, you would in fact have a beach even if you didn't have sand and water there. So the idea of the project was to take a series of surfaces and just mutate those surfaces along their length so that the performance of every one of those programs happened along that surface. And as the surfaces connected to each other, they would become the structure. And it was really a kind of breakthrough for us where it was this notion of thickness that actually still drives a lot of the work today. This idea that surface, structure, and program can be blended into a single element that begins to kind of have effects, think about how it's made, has an aesthetic, and drives the whole thinking behind the building itself. So this is the actual model that we did. I know you can't really see it, but it's a really beautiful drawing if you could. And the idea of the structure was a very simple one, a kind of A-B system of sticks that went together. This is the complete set of construction documents. These are actually, each one of these drawings was 15 feet high and 32 feet long, full-scale templates that went down on platforms. And basically, you took the 2 sticks, you followed a system of color codes, you crossed them over, you hit it with a stainless steel screw, and you trimmed the 2 edges. And then the Z coordinates were listed in numbers at the bottom. And basically, the pieces went together. And we had 3 weeks to design it and 3 weeks to build it. Now it's a much longer period. They sort of didn't know what they were doing right at the beginning there. And $50,000 was the budget to do it. So it was a fascinating project. We finished it 3 days early, and MoMA was nice enough to then give us the space to throw a party since we were done early, which we had a great party there. But Dunescape got built, and it was kind of the first time we really got those things together. You could see we did a forest of steel trees that blasted mist into the courtyard, the kind of smooth transition between sort of seats and walls programmatically and structurally, and then your typical day at Dunescape. Now, I'm sure many of you know the PS1 competition at this point. So the year before we did it, an architect named Philip Johnson had done the installation at PS1 and did a kind of cool tower thing, and he actually got up there and spun records as a DJ. And you know, at the end of the summer, it was interesting because we knew it was getting taken down. And we thought to ourselves, you know, I kind of looked, we got great press and it was on TV and 60 or 70 articles and it really seemed like a success. So I asked Alana Heiss, who is the director of the museum, I said, so how did we do this summer? And she said, well, it was great. I said, she said, you know, well, last summer we got 2,000 people every weekend to come out here. I said, how did we do this year? She said, we got about 8,000 people every weekend. And I sat there and I thought, 6,000 additional people every weekend times 12 weeks, times a $10 admission fee, times an actual, you know, a guess of about 2 beers and a hot dog. We just generated $1 million in revenue for the museum, and our fee was $15,000. What's wrong with architecture? But some great things came out of it. Richard Branson came to see it and hired us to do a piece for him at JFK for Virgin Atlantic, where we started pushing this idea of fabrication and the sort of absorption of mechanical lighting and other elements, programmatic elements, into almost a building, a pavilion that got built inside a building. To an arts complex we did outside of Seoul, Korea, at the Harry Valley, which was the first time that we had to make, we were always very involved in the construction, but this time we had to let go of it. So how do we make the drawing strong enough that if we weren't there, the building could come out the way that we were hoping to do it? To then winning a competition for the Fashion Institute of Technology to build an academic building for them. Here the idea of performance-based design was that in a design school we felt that the 3 things that mattered were sort of critiquing your work, exhibiting your work, and circulating your ideas. So basically the entire thickness of the facade, the 20-foot thickness, became this sort of woven loom, if you will, of the crit spaces, the exhibition spaces, and the circulation spaces, so that literally the act of design school inhabited the thickness of the facade itself, and it became something that was demonstrable from the street. But as we started to try and build things like this, especially in New York, it's got a pretty tough construction industry who was not terribly interested in innovation. So we realized that more and more that if we wanted to get these buildings built, we had to engage the construction side. And I think one of the first times we were able to successfully do that was at our park in Greenport, New York. So this was also a competition that we won. Greenport's about 2 hours outside of the city on what's called the North Fork of Long Island, almost right at the end. It's a kind of fishing village. Wasn't really a kind of summer colony quite yet. It's kind of changed over the last few years. But they had a 4-acre empty lot. This is sort of Main Street with all the stores. This is looking out to the water. And there's a ferry here that takes you to Shelter Island. And so we developed this idea of a kind of necklace that all the programmatic elements would go off of. There was an amphitheater. The town had a historic carousel. We built a carousel house, a ferry terminal. This is a water garden that turns into a skating rink in the winter. And then this tiny little building here, which was a programmatic request from the mayor, which was to build a folly, and he wanted a camera obscura. So by the time this project took over 3 phases, almost 8 years to produce, and by the time we got towards the end, towards the camera obscura, he had enough trust and faith in us that we asked him if we could use that little building as a pure R&D project for our office. So here you could see the carousel house and the ferry terminal. And so he said, sure, go ahead, try it, see what happens. So this was the first time that we just tried to make a pure performance wing out of the building itself. And so we had a series of programmatic elements. We had a kind of minimum surface that would, in that thickness, enable the structure, the program, and the surface to come together. And basically the camera had a lens on top and with a 45-degree mirror that would project an image of the whole park inside this dark room onto a large table. So this is 2001-2, just to give you some dates. So what we decided to do was to, I like to call this BIM version 0.1. So we actually just modeled all 2,800 parts in the building physically, and no two were alike. And we began to make our construction documents. These are the actual CDs. So you see every different material in space where it would eventually be. And you had two kinds of drawings, obviously, the drawings that explained how to make it and the drawings that explained how to assemble it. And these are not cleaned up presentation drawings. These are the actual CDs. And we were able to even measure what the composite assembly pieces of each part would be, so that we could measure the weight, so we knew that none of them would ever be too heavy that two workers couldn't lift it, to eliminate specialized equipment on the site. And you just end up with this sort of like fold, bolt, screw. These were the instructions on here. So it wasn't until the end that we looked at the drawings and we literally started laughing at each other, because we realized there were no dimension strings on any of the CDs, because they were now totally irrelevant. Basically, all the parts were manufactured by the computer. They all arrived on site. They were all slotted, numbered, drilled, and basically the building popped together like the most kick-ass piece of IKEA furniture you've ever seen in your life. So those are all the parts that it took to make. This was actually an art piece we made for the Cooper Hewitt Triennial, using the same model, just printed it at 1/10 the scale. Even the formwork was all milled, so they just had to shoot 4 locations with the surveyor, full-scale templated out. The instructions for making the building were cut into the parts, like weld, 3/4 inch fillet weld from here to here. They never had to look at the drawings. And the other amazing thing is the contractors never had tape measures on their belts, and we knew that if you ever heard a saw go off, something was going wrong, because you can't cut a piece. So the building went together in 6 weeks by 3 guys. Everything fit, and the detailing turned out really well, and how it sat there. So, there are a couple things that we learned from this. One was, here's a public project, which is always a sort of very volatile process, and the 4 bids came in within 1% of each other. And that was fascinating, because what we had done is we had removed the risk from the contractor's side, and there was such certainty in the pricing that the client was super supportive of going ahead with this, supposedly radical building. We would never, ever say that you build a 70-story building or an arena this way, but we did learn that there was something that you could do. There were ways that if you wanted to push design, push the aesthetics, push certain parts of your building, that you could gain control, take all that territory back, hold it inside the office, figure out how to do it, and have such a good solution that it just never gets value engineered out of the project. And that's really where a lot of this comes from. And we realized that we were doing things very much the way the aerospace industry was making their planes. So the project got finished and was a success, and then it was a very interesting thing, because there was now a large competition that was happening for a park in New York City, and one of the key requirements to even enter the competition was that you had to complete a waterfront park in the state of New York to be considered to do it. So that was fortunate for us. And so we went after this project to do this 2-mile esplanade that basically goes from the Battery to the Lower East Side. And there were 40 years of projects along this site. And the first thing we did was we went to look at the history. Some phenomenal architects have proposed amazing projects here, and we started thinking, like, why didn't they get built? And there's obviously a lot of reasons, but one of the things that we felt was really important was connecting the sort of 6 or 7 different neighborhoods from the interior out to the edge, rather than thinking about it as a big object that goes on the side of Manhattan. We looked at the sites. It was remarkable. In a way you can kind of think about it. This is some of the only truly south-facing waterfront property in New York. Literally a 5-minute walk from the 3rd largest central business district in the country, and yet A lot of it was used for garbage dumps, salt piles, beautiful 18th century squares that were used as parking lots, infrastructure blocking people's ability to move through there, or even then places right here where there's so little open space. Here's an entire river and open, here's all this incredible space on the waterfront. We found places where there were up to 14 layers of chain link fence between where people lived and the water. Or you had these large sheds on the piers that wouldn't allow anyone to get out there. So the next thing we did was we leased a helicopter, and we asked them to fly us over all 400 miles of waterfront in the 5 boroughs of New York and just shot pictures like every second, and developed a taxonomy of waterfront types and started to look at the ways that things work and don't work. And eventually, what happens on the current Lower East Side is you've got Water Street, which is a successful street. Front Street's a kind of back service street for the towers here. And then you have South Street, where you've got this really wide street, truck parking underneath, the FDR Drive above, fences and sheds. And at the end of the day, the thing that we realized that was really keeping people from here going out there was the distance between the curb here and the curb there, that sometimes stretched 120, 130, 140 feet, not signalized, ducking under a highway, and people just felt afraid to go there. So we said to the city, look, get rid of the parking. Anywhere you can plant a tree, get the bike lane in going around the perimeter of the city. And instead of complaining about the FDR Drive having this big structure in your park, why don't we think of it as a free roof? And why don't we just hang very lightweight walls off of the FDR Drive and create programmatic spaces where you can now bring the city out to the waterfront, where you could have cultural venues, you could have commercial venues, you could have community venues. So that was the major idea that we had. And then the last thing was we said, since you can't expand the footprint of the piers, the amount of square footage that shades the bottom of the water for environmental reasons. So we said, but people are so desperate for open space here, why don't we start considering making double-decker piers so that you could have passive recreation space on the top, marine and active recreation space on the bottom, and you get a kind of 2-for-1 for every foot that you shade over the river. So again, this was probably about a 6 or 7 year project. And it's going to continue for 6 or 7 more years as they build each phase. But the first phase opened about 1.5 years ago. So we developed, using ductile concrete, a kind of system of sort of crate-like park furniture. We used these precast concrete walls to allow us to build up soil high enough so that we could plant trees. So you can see as you come out from underneath the FDR Drive, the kind of plantings that we were able to get in what used to be parking lots for buses and trucks. People sitting on the walls. We worked with Ken Smith Landscape Architects on this project for all the years. One of my favorite features in the entire park is, and this always frustrated me, every time you go to a waterfront, you go and you sit down at a waterfront thing, and the 42-inch rail is exactly where your eyes are, right? So we spent about 3 years arguing with the city that all seating on the waterfront should be bar stools so that you're up higher and you can look over the top. And so you can see that the railing goes from 6 inches to 18 inches. You have these much higher stools, and they put them in, and they are absolutely the most popular stools in the whole park. They're always the first ones to get filled up. People come, they bring their lunch, they bring the paper, they bring their laptop, and now the city is starting to put them in all up and down the entire river. So that's great. And then one of the key things is you get down to a park, and for me, especially go down to the waterfront, like, it's amazing at night. It's dark. You see the sort of twinkling lights of the city. You see the ships going by. So the last thing we wanted was kind of big, glaring lights in your face. So one of the main design strategies was to sort of embed all lighting inside materials and have it only bounce off another surface before it comes into your cone of vision. So we got the city to paint the main girder of the FDR Drive lavender. You should have seen DOT when we showed them the 30 choices of lavender that they had to pick from. We hid the lights up in the structure. The light hits the lavender and casts this beautiful glow on the waterfront. And it's remarkably romantic when you're down there. Everyone who goes there on a date says they have a fantastic time and definitely makes out. So then on the pier, we did this double-decker pier. It's got this big sort of sun deck. It has a series of glass boxes that have green planted lawns for roofs that become picnic lawns on the top. You can see the plantings on the outside. This opened about a year ago. Here you can see the glass box comes right through and becomes these lawns that you can sit on. So that's all basically invented space. And the remarkable thing was that the additional cost for the second floor, once you've already built the first floor, was minor. I mean, it was like $150 a square foot. How valuable is open public space in the city of New York? It's 20, 30, 40 times that amount. And so now it's a model that the city is really starting to think about for many of the piers. Here you can see there are sort of these get downs to get closer to the water. And then the ceiling, we didn't want you to feel like you were underneath another FDR drive, so we made this kind of supple series of recycled material sticks. We hid the lights up inside. They bounce off the galvanized structure and give you this kind of amazing glow. That's not a rendering. That's what it looks like done. It's really been quite a success. It was a remarkably inexpensive project to build and gave us about 75,000 feet, almost 2 acres of open park space to the city of New York. So working on the public project here, you can see Pier 15, the double-decker pier. These are our first sections. It was amazing because then we were introduced to the developers who had purchased the South Street Seaport, the old Rouse property, the Pier 17, and they loved what we were doing at the park and asked us if we could reimagine what could happen with their site. So in 2006, 7, and 8, we developed this plan where, working with James Corner this time at Field Ops, we proposed putting a 3-acre park, knocking down the existing pier, putting a 3-acre park in the middle, moving a historic structure that was originally a waterfront building out to the front to recreate it as a phenomenal food market, and moving all the FAR into this one tall, slender building that had sort of retail, hotel, and residential above. These 3 sort of glass boxes hanging from a steel superstructure. Exoskeleton, I'm sorry. So again, here you see the retail. This is a boutique hotel. And then the tower as it went up above with this kind of shifting pattern of the facade that was relating to the program behind it. So amazing project. We got it about, I'd say 80% through the approvals process when the sort of financial crisis hit. And General Growth Properties, who is our client, ended up becoming the largest single real estate bankruptcy in the history of the United States. They went from a $66 billion market cap to 0 in 4 months. The fascinating thing about it was not the company that was in trouble. It was that they had purchased all their assets on their buying spree with short-term debt. So all their debt needed to be refinanced in 2008 and 9. Not possible. Company goes down. So they've emerged from bankruptcy. They split the company up. And now we're starting to work on a series of other buildings on the site. Now the Howard Hughes Corporation came out of this company, and we're working on a kind of series of buildings that are going to make a completely new neighborhood out here with a series of streets that open up and allow sort of boats and water in, retail out, sort of cultural facilities go on top. And we've been working on this one for about 2 years, and on Wednesday got final approval from the City Council to begin taking down the existing, but not easy to knock down several buildings inside a historic district in New York. Full unanimous approval to start taking this down and reimagining it as something else. Working with the city so closely, we ended up meeting our mayor and working with a lot of his team, and were put on a paid competition that we worked on for almost a year to build Bloomberg's headquarters in London. An amazing project. Ended up with a lot of very well-known architects. Ended up then for a second round with a final 2. It was this whole thing about the way that the media company works, connecting it to its kind of local condition, having this whole sort of series of of volumes that cut between the streets, that the building became incredibly porous. And with all the incredibly strict height restrictions and view quarter restrictions of London, how to make a kind of object building that would read as a piece of sculpture on the skyline. This would be the image taken from the terrace at the, I'm just blanking for a second, Herzog and de Meuron's building. Tate, thank you, Tate Modern. And so phenomenal project. We thought we had it won, and at the last second, shocker in London, Norman Foster got it from us. But you know, that I'm not bitter about it at all. You know, but as we started doing these things for our clients, they started to hire us in different ways, not only just as architects, starting to rethink how they actually thought about buildings, how they thought about their space, how they even thought about some management. But you know, one of the things that was a tricky thing for us was, you know, this is what we call the cycle of mediocrity, right? And this is a kind of important thing for people to understand. I think that as we were doing some development work, you know, there's always this kind of criticism of the developer here. And, you know, what we determined was the developer isn't really the bad guy. This is the bad guy, right? And the reason is and the reason why there's so little innovation and so little change in the way that buildings get made, and a lot of it is because basically the developer proposes a project and the lender says, sure, I'll give you the money as long as you give me the comps, right? And the comps are short for the comparables. And what are those? It's show me the 5 other buildings in this neighborhood that had the same layout, the same material, the same basic look. Tell me what it cost to build, tell me what you sold it for, and if it pencils out, I'll give you the money. And if it doesn't, you're not getting the money. And of course, what are the comparables? Well, it was the only product that was available. It was the only thing the real estate brokers had to sell. It was the only options that the purchaser really had to buy, which drove some false sense of sales data, which tells some marketing team that this is what people really like, which then the interior designers say everyone really wants granite countertops. I don't believe everyone really wants granite countertops. And then puts this whole sort of design team in a really tough position. So we started thinking about, well, how do you begin to break that? And you know, one of the things that we thought about with how the space gets made and how capital A architecture can begin to sort of integrate with the making of things and push that system in a different way was thinking about the idea of taking risk. And that, you know, as a developer, as a lender, and as an architect, you need to start to work together and take on greater amounts of risk if you want to push forward what we're doing. So the problem, though, that I have is that a lot of, and I'm not blaming architects, but there's just been something about, maybe it was because of that split that we talked about at the beginning, but so much of what we're told is to try and avoid risk. Don't sign this. Don't get involved. Let the other consultants do that. Let them do. And when the more and more risk you give up, then the less and less reward you get on the other side. Now, you know, sometimes we do act like the butterfly flying around the monkey's behind. And we've got, as a profession, the fact of the matter is that the intellectual contribution that we give is probably the most. We're a profession, we're the last great generalist profession. And yet, somehow we keep getting forced to want to be specialists, to just make the image of a building. But we truly believe that the more risk you take, the more you get into the thickness, the more you think about the politics behind the building, the way it's made, the financing structure, the aesthetics, the history, the art, bringing that together, that's an amazing thing. And that's what we have to offer. We don't just make images. And that if you wanted to really start to change the way in which, don't complain that architects don't make enough money, you've got to take risk. That's what we do in this country. So our whole feeling was that you had to try and start to double down. You had to be willing to know all of that stuff, know the history, but be willing to make that connection, make that dedication, and try and push the way in which a building gets made. So the first time we were able to, we tried it. We had no idea if we were right, by the way, and actually I'm still not entirely sure, but I'm pretty close. But what we did was we found a 6-story building in New York City on 15th Street, and there were a bunch of people chasing that building. Now, the FAR in this neighborhood was 6, so the building was built full. But there were 2 historic buildings to the south of it that were not built full. So our first idea was to buy the air rights and put them on top. A few people had that idea also. And we had a 120-foot height limit, and we had a 15-foot setback. So the only way you could increase the square footage of the building to get a theoretical future revenue source, assuming that you would make money on each additional square foot, was to make the building a little bit bigger. So the only way to go was to cantilever over the buildings to the south of us. And again, this is early 2000s, so now something that's done quite a bit in New York, but at the time wasn't that much. But the problem is that the more you push the cantilever out, you get a sort of decreasing rate of return, because the cantilever starts to get so expensive, it sort of supersedes the additional revenue that you're going to get. So the trick was to think of the least expensive way to get the cantilever as far out as we can. And working with Bureau Happold, we came up with this kind of system of a renovated 6-story masonry building holding a brand new steel and glass contemporary building with a 2-story couple that made a 10-story building in total, with a new core in the center that dealt with our overturning 32 mini piles drilled 90 feet into bedrock below, half of which are in tension, half of which are in compression. So the new core sat in the middle. We were going to make these condominiums, residential, with retail on the bottom. The idea was to have 3 exposures, basically 2 apartments on each floor. And our idea of contextuality is that the building, the new part of the building, should look nothing like the part that it stands next to whatsoever. So we thought we wanted to try a metal building. We had never done a metal building, and we thought, so here you can see this sort of new facade, and basically the idea of the facade was to have 3 panel sizes, 4 window sizes, and 2 light box sizes, and to blend them together into this kind of new shape and form on the top. So we drew up parts of it, the ideas, and immediately we went to the facade manufacturers and started asking them about it. We only like to work in natural materials, so we wanted to do it in zinc. And we went to these guys and they were like, yep, at the time, let's say like the worst cavity brick curtain wall was like $50 a square foot, like a nice metal building, $60 a square foot, The Richard Meier towers down in the Village were probably $120 a square foot. And we said, well, how much would a zinc metal building be? And they said $95 a square foot. So we said, well, why? Zinc only cost about 15 or 20% more than metal, and the material is only about half of the cost. Like, what's up? And they were like, well, too bad. That's what it costs. We don't want to do it, so we're going to charge you more money for it. So then basically we just said to them, well, where does zinc come from? And they said, mostly it comes from France. So we got on a plane and we went to France and we bought 1,000 sheets of zinc and we brought them back to New York. And we took these 1 meter by 3 meter sheets of zinc and we designed the entire building so that either 1 unfolded panel, 2 unfolded panels, 3 unfolded panels, all the pieces worked on the layout. We had a 96% use of our raw material. There were about 22 protoforms, about 400 different shapes of zinc, producing 4,000 unique pieces in and of itself. And we went to SolidWorks, because how could we do all those shop drawings? We were about a firm of about 8 at the time, or 9. And so we fed everything basically in a spreadsheet that went directly to the laser cutters. Cut out all the panels. There was a kind of code system that explained where the pieces went on the building. So literally the instruction set of putting the building together became the architectural detailing. It's still there today. We started at one corner, went all the way around the building, and we got to the end. We were 1/32 of an inch off with 0 shop drawings whatsoever. We also delivered the wall for $43 a square foot. And we said, all right, this is a good idea. So. But the building itself, one of the things is the sort of the play of light and shadow, and the way that it integrates with the historic building that we renovated. And one of the things I absolutely love about this building is the sort of boxes that in the push and the texture of the way in which the pieces, the detailing is attained. And pushing the glass back 14 inches was something we really wanted to do. But of course, 300 windows pushed back 14 inches, you create 300 ledges, and we have a pigeon issue in New York City. So we called the Museum of Natural History and asked them, was there an angle of repose that a pigeon would not want to land on? And they said, yes, it's 34 degrees. And we actually produced a 34-degree, it was the part was actually labeled PS, like 226, which stood for pigeon slide. And the pigeons actually land on it. They go like this, and they fly right off. And I'm incredibly proud to say that 10 years later, there's not one bird shit on the entire building. We did the collateral materials. We did the interiors. We brought it to market and sold it. And we sold it at about 17% more in our sales price than all the other, let's just say, high design first architects that were building in the neighborhood, yet it cost exactly the same as building an entirely standard building. And so we really kind of saw that design is a profit center and can be a profit center, and that being smart about it, taking that risk, we put everything we had into this building and rolled the dice on our entire firm. And that was enough to help us then get back some money that we can invest and start to grow and build the practice bigger and bigger. It's led to some crazy projects. This is one that just came out a couple weeks ago. This is in Williamsburg. We were just given a project to do 3 million square feet of offices and buildings. So this is in the middle of going through the approvals process. Again, a large park we're doing with field ops, and a huge change from the previous plan. These are 60-story giant donut buildings. It's obviously somewhat controversial. These are not the facades that we're going to do. This is just to get it going. But you know, it's funny. Literally within 6 hours, oh, here you can see down from there. Within 6 hours of this going public, Curbed changed our rendering to this, where now it spells SHOP, where they had said they're taking over New York. Again, it's from that little building and taking that risk at 50,000 feet. Now there are just a lot of people asking us, how do you apply this at much larger scales? Can we get those cost savings to pour it back into public space? Are there other things that we can do instead of business in the normal way? Some of our clients asked us to think about buildings in different ways, working for a large company out here, thinking about how to plan, how to think about the performance of what an office building could be, about the different kinds of relationships, about the most sustainable practices one could have with a kind of energy blanket that then carved into the building to allow technology to change over time. Actually showing different ways by addressing the way in which certain ideas of the client would be put in front or back, and thinking about those, how it would have a radical impact on form, and what did that mean creatively? What did that mean to the way in which one occupies the space and occupies the building? So an incredible project that we worked on that unfortunately didn't get built also because of the financial crash. But one where we then took a lot of the research and ideas that we had developed here and entered a competition in Botswana, Africa. So we took these ideas, we took this notion of the dune and delta, the two major sort of forces of natural forces in Botswana, and started to think about it for this innovation hub, where you had a kind of series of bar buildings, these kind of performative pockets that allowed for different kinds of environmental interaction. And this was the image of the government complex for the competition. And funny enough, it came down to Norman Foster and Shop again. And this time we luckily won. One of my favorite parts about this project are these beautiful 150-year-old trees. And we left, the parking all needs to be covered. So it sits underneath, and we mounded up the site around it and then left holes so the trees come up into the courtyards themselves and create these kind of shading devices. And you move through these glass bridges through the treetops between the different elements in the building. Huge amount of performative design ideas with the way in which the facades work with the climate. Again, the kind of models that we were producing, so taking sort of traditional basket weaving techniques and developing it into facade systems, figuring out how to do knowledge transfer, where we're actually down in the schools in Botswana, teaching everyone how to use this software, how to fabricate these things, how to push their building industry. Wow, it's sort of going automatically now. All right, let's keep going. And what the building will look like. It's under construction right now. It's a 300,000 foot building. That's the heart of a 3 million square foot campus this is what we are expecting it to look like. Sort of drive in through the dunes here, and you move under the building, and then you can see the facade of the different elements with the courtyards inside, and what the view will look like from here, from inside. So it brings me to the Barclays Center. Some of you may or may not know about this project. So it was a 10-year project that Forest City Ratner Companies of Brooklyn had developed with Frank Gehry as the master plan architect. And Gehry did an incredible, a highly contentious project. Involved eminent domain, involved 34 lawsuits against the developer to try and stop it. It's in basically a brownstone neighborhood in Brooklyn over what was an old abandoned railroad track. And the Gehry design was, quite frankly, an incredibly brilliant idea, in my opinion. It was really this notion of not just making an arena that sat as an object, but the idea was to have 4 large towers that you can imagine had very large foundations that literally held the bowl of the arena in the middle. And at the end of the day, actually, 80% of the arena was not visible. There were only these 2 spots where it sort of poked out. Now, the way the press likes to talk about this project at this point was that when the crash happened, they couldn't afford the Gehry Arena and that they had to go with a cheaper solution. That's sort of true, but not really. What happened was, in 2009, those 4 towers around the building were not financeable buildings. They couldn't get the loans to put those buildings up. So you now had to redesign the entire structure. So this is March of 2009, and Bruce Ratner, the visionary leader of Forest City, went to Frank and said, can you redo it? And as he should, he was like, yeah, sure, but it's going to take 18 months, 2 years to put the drawings together. Well, the problem was that the tax laws in the United States were changing, so that if you weren't in the ground on the stadium by December 31st, 2009, the tax bond financing was no longer tax deductible, which would have been a many, many hundreds of $1 million hit to the project itself. So our client was in a tough space. He wasn't our client at the time. And he went to Hunt Construction, who I think are the preeminent design build construction firm and do a lot of NBA stadiums. And they said, what do we do to get in the ground in 9 months? And they said, it's basically impossible. Your only hope would be if we get on a plane and go to all the stadiums we've built and you find one that you like that fits on the site in Brooklyn, and we have the steel drawings and we can order the steel tomorrow. That's your only hope. So they went and they found Conseco Fieldhouse in Indianapolis. That was done by Ellery Beckett, now AECOM. They hired them and they took the Conseco Fieldhouse and they dropped it on the site in Brooklyn. And there was a very unfair sort of position for AECOM to be in, because they were told to do that, but unfortunately the city of New York saw it as a terrible bait and switch in some way. So it caused a huge issue, and it hit the front page of the New York Times. It was a huge battle. Anyway, a couple months later, we got a phone call out of the blue. Never met Bruce Ratner, never knew anything about them, but I saw it came up on my phone, Bruce Ratner. So I actually asked one of my mentors, I showed it to him, I said, should I answer this? He said, yeah, you should answer it. So we answered it, and he came in, and he said, well, do you know who I am? Yes. Do you know what my problem is? I said, I'm assuming you're talking about Atlantic Yards. He said, yes, I'll be in your office on Monday at 5 o'clock. Can you have 3 ideas on how to fix it? So we did these concept sketches, but it wasn't until he came in that we found out that the steel had been ordered. And we were like, well, we don't really do facades on other people's buildings. It's just not what we do. And we had a great conversation for 3 hours that got into a kind of whole metaphorical conversation on couture dresses and design and a bunch of other things. And literally he walked out and he said, you guys are great. When this recession's over, I'm going to give you a call. Talk to you in 3 years. And And we went out, my partners and I went out that night, and we just started talking, and we just started saying, like, what could you do here? Could you strip it down? Anyway, we came up with one idea. We called them back the next day, and we said, look, we'll work for 72 hours, and we'll produce one image. And if we can prove that we can build the image for whatever your delta is you're allowing, up to 50 million, he told us up to like 50 million more in construction cost over the original design, and we figure out how to do it, then you let us do the whole thing. We get to go back inside, we get to take it apart, we get to do a lot of different stuff. And he said, are you willing to do that? We said, yeah, okay. So we worked like that, and then sent it in at about 6 o'clock on Friday, and didn't hear anything. One image. Didn't hear anything. All day Monday went by, didn't hear anything. And by like Tuesday morning, I was thinking, like, oh, maybe it didn't go through. Maybe they never got it. So I called the head of construction, Bob Zana, and I said, Bob, about that image we sent you, you have no idea how many problems that image has caused over here. And I was like, yes, we got the project. So the idea was to take the steel and to think about the building on three scales: the scale of the pedestrian, the scale of the neighborhood, the scale of the city. And I've only shown this a few times. This is actually the first sketch that we did. And it was this whole idea of really trying to be inventive about a stadium that's not about parking. There's not one parking spot in this stadium at all, not one. But 11 subway lines come here. And so the whole idea was to make the front door by coming from underground and looking up, and to create this new kind of space that became a new kind of urban vortex. And here you can see the original sketches. Now, one of the funny things is 3.5 years later, we looked at this image, and none of the partners who were here that night that actually drew it have any idea why Toyo Ito's name is on this drawing. We have no idea. But clearly, it's good luck to have him on our drawings, because he's obviously since won the Pritzker Prize. So we promise Stephen Hull will put your name on the next sketch that we do. So again, breaking down the massing in these sort of bands, the idea was to make the concourses open up to the city, to really think of it as a kind of urban machine, and to turn all the retail not facing into the concourses but out to the street, so that all the times when the stadium is not being used, it's actually a lively retail street. And then to make this sort of very large sort of entryway, we kind of called it the arms of Bernini hip-hop style, come out in the front here with a very large oculus so that you didn't feel like you were under this huge element. And again, the whole thing about coming out of the subway and opening up the bowl itself, so that from the public space you could see right into the bowl and see the scoreboard itself. And then you look up through the oculus as the sky as the kind of main entry sequence. We thought about so happens we used the Domino sugar plant, but thought about the kind of industrial Brooklyn past, about the idea of technology in Brooklyn, and how to think about something that was both simultaneously very forward-looking but gritty as well. And that's the image that we sent. Again, I've only shown this maybe half a dozen times. That was the single image that we sent to Forest City that Friday night of what we thought we could turn the building into. When they asked us to do it, they said, you have 7 weeks to completely design this, detail it, cost it, and hit that delta in price, or you're gone. So we worked around the clock. We had about 28 people working on this one project. And in 7 weeks, we had that image. And 2.5 years later, that's the billion-dollar project as it finished on September 28th. And to me, we didn't ever put these three together until after it was done and looked at it. But the only way we were able to get this done was to really think about how to get it built, but how it was going to act as a kind of urban machine, how it was going to interact with the neighborhood, the notion of the interiors, the steel folding inside and becoming the interior elements of the project, the idea of the Brooklyn night, the sort of wet street, and the was the kind of aesthetic drive on the concourses. All of the steel ribs that hold the panels in place fold in and become the light rails. All the concession boxes become these sort of rusted steel Donald Judd-esque boxes and these kind of all black walls, using different materials to really kind of change the way one would think about a stadium, the main entry sequence, the different sort of club spaces. And then one of my favorite parts of it is that we suggested that the entire bowl be black, that no color, no nothing, that sports is the greatest theater with an unscripted ending, and that it should feel like black box theater. We proposed putting boxing lighting in and a very dark floor with black and white uniforms, completely changing the vibe of what this team was in New Jersey to what it was going to be in Brooklyn. And then the facade was made up of 12,000 folded plates of basically a kind of weathered steel, like a Core 10, that folded in, and then when they folded, we hid the lights behind there so that they reflected off the folded pieces of steel so that it kind of glowed in the night itself. But the only way we could get this done was by knowing how to build it, because it was incredibly complex. So again, the CATIA models, the unfolded 12,000 panels, and shop construction led this entire part. So basically, shop construction basically JV'd with the contractor while shop architects was working with the client. And all together, by completely eradicating that diagram that I showed you in the beginning, was the only way we got this thing built. So the different kind of panels, the original mock-ups, all the fabrication drawings produced by shop construction. And then what we did was we cut the parts and they were hung on a dry cleaner rack in a factory where they went through 15 wet dry cycles a day for 4 months to get 10 years of rust patina on them. Here you could see them in a dry cycle hanging. And then we wrote our own iPhone app so that you could go up to any panel at any part during the entire process, scan it, see the 3D model of the building, know where every part was, what mega panel it went on, where it was in the weathering process, where it was between the factory in New York, where it was laid out, and how it would go on the building itself. So everyone, this is what would pop up when you looked at the iPhone app. Everyone from Bruce Ratner to a guy with a wrench in the field had the same information. And that absolute clarity and transparency is what transformed the ability to do it. With this kind of feedback loop, we were learning what we were doing as we were designing. Here are the panels being loaded up. And then even as the steel was going up, we were cloud scanning the entire building and then lining it up to our digital model so we could find out if any of the plates were not in the exact right position. We found that almost 12% of the plates were not in the right spot, but it was fine because we could correct it now so that it wouldn't be a problem when the panels got out there and got put on the building itself. Saved probably 3 months in the construction process. Here you can see us aligning the scan to our digital model. The pieces going on. You can see as they were lifted into place. So there were 921 of those mega panels. You could see the pieces as they went onto the building. No two of the panels are the same. And then here was the oculus. And the other idea we had that we thought would be very different was turning the digital boards to the inner ring of the oculus itself. So they didn't blare out into the neighborhood, but that they created a new kind of space. And we love this idea that when there's not a game on, you could do a sort of live feed from Prospect Park of a bucolic scene and sit there and look in, and this is what you could see. That's the scoreboard inside the bowl that you could see from the public space. Incredibly complicated piece. This is an 85-foot cantilever by 210 feet wide. Just to give you a sense, an NBA court fits inside that oculus. But the complexity of the parts, and literally our guys were hanging off the steel with them, showing them iPads with the model, spinning the model around. They didn't want drawings anymore. They just wanted to look at the model and put the pieces together. You get a sense of the scale. And then the panels as it was going on towards the end, the digital board going in, and then what it looked like when it opened, the back. This is the loading docks. This is where a future tower will go. What it looks like as it's sort of nestled into the street. And I mean, I just feel very strongly about it that while it's a kind of really risky choice of doing it in this Core 10, it somehow connects with Brooklyn, and it's clearly a totally progressive and new building, but I feel works very well in its context. You could see as the program changes behind the screen, the openings change, so you get different places where it closes down and opens up for views. What it looks like as a game is going to start. the lights reflecting off the folded steel. Sorry. Looking under the oculus. And there's even commissioned art pieces that go on here at different times. Coming in the main VOM. Looking at the concourses. Different concession stands. The all-black bowl. These were the first things that were said on the days that it opened. I just put that in there for you, Ed. The VIP entry, some of the bars and different club spaces, the Vault Club, and the bowl as it goes. And it's just got a completely different feel than any other arena, I'll have to say. So coming down to the very end, 5 more minutes and I'm done. Perfect. So the interesting thing was that the first 3 towers around the building, our client challenged us to say that could we rethink the construction process. He was, I think, so happy with the way we pulled off the arena. He said, why don't people do more modular construction? Why does it only have to be low-rise when it's done? And because there's a high percentage of affordable housing necessary here, can we rethink the whole idea of building a high-rise modular building? So there were very prescriptive zoning envelopes for what we could do, but we worked on an idea of trying to break up the blocks to make this housing project. And we had 2 parallel teams, one working in conventional methods, one working in modular, that made 2 full sets of drawings that then went and bid against each other. And the modular won. And so right now, so you can see it's basically a series of steel boxes. The first building is 34 stories tall. The mods are built with the bathrooms, the kitchens, all prefabricated, the steel, the facade goes on, the light switches, the flooring, the lighting, completely sealed as a product made in a union factory in the Brooklyn Navy Yard and driven over and stacked 34 stories tall. We worked with Arup on this to develop the mate line details, the bracing, the core, everything modular, completely produced in a factory. Even the facades have self-sealing gasket systems on the outside, so the facade of the building is already on the mod when it arrives, and there is no scaffolding needed when you put the building together. You just stack them up, and hopefully they don't leak. Here you can see the sort of details at the bottom and the way that those panel pieces come down. The different types of mods, so there's 36 mods for each floor. And basically inside the apartments, in a fairly standard design apartment, again, we had to have comps. The only thing that you would ever tell that it's different is that this wall is slightly thicker than in another wall because that's a mate line between 2 steel boxes. But you can open the whole thing up. That's a mate line as well, right through that element. So, you know, thinking about all the ways one can work. So we were saying, like, taking on risk at places like the Porter House, or other projects where we took equity positions in our buildings. Now, some of those were successful and some of them weren't. Some of them we got crushed by the collapse, but it didn't matter because we ended up inventing, you know, a half a dozen or a dozen projects that we never would have gotten. We ended up learning incredible things about how our clients think and how to make buildings. Shop construction, as I showed you, with its sort of VDC services, it not only works for shop, it works for other architects, it works for other contractors, helping them take the things that shop has learned in the last 15 years and letting anyone work with those ideas as well. And if we didn't have that ability, there is no way we get this building built. And shop applications, just looking at kind of inefficiencies in the market, thinking about what we all do every day. One project we're working on right now is a program called Envelope, that takes the New York City zoning code, completely analyzes where things are built and overbuilt and underbuilt. It takes some basic data from the city and adds into it a GIS system where we've remapped the entire city of New York. It takes zoning code, 3D massing, and investment metrics. And basically, you click a couple of boxes here on the right, and what normally takes a zoning attorney or an architect 5 or 6 hours to complete, it completes in less than 60 seconds. And you can toggle with the floor-to-floor heights and the different zoning choices that you have. It makes your 3-dimensional model that outputs it to Revit and outputs it to Excel to run your pro forma. So we're in the last bits of sort of trying to raise some VC to get that product to market, hopefully in the next year or so. And to Helioptics, which is a sustainable technology. It's basically a daylighting control system and photovoltaic curtain wall that you can see through. So no longer does a solar panel only have to go on the roof of a building, but it can go on the entire south facade itself. So what I'm saying is I'm not calling for a new period, I'm not calling for a new style, I'm not calling for a new time, but I think what we are calling for is to take advantage. We were the master builders. We have an amazing profession, and we have an incredible ability to use this moment. It's such a good time to be a young architect or a young professor and to be thinking about these things, about what we need to teach in the academy, how we need to take advantage of all these territories that we've systematically given away over the last 30 years to use this paradigm shift in technology to then grab it back and think about beautiful buildings that inspire people, that make cities great, that make them sustainable. You know, the most sustainable thing you could do is not hang a photovoltaic board on a building, or as many of them as you can. The most sustainable thing you can do is build buildings that people love, that they will take care of, that are efficient, and that don't need to be renovated every 20 or 30 years. And the most sustainable thing we can do is make dense cities that have high qualities of life. Well, quite frankly, the people in this room are the people who have the best ability of knowing so many things from our generalist profession to make this happen and make our cities someplace great to live. So it's about taking on risk, it's about thinking about reward, it's about thinking about changing the way that we design. And if you do that, you can go from this to this to this in 12 years flat. Thank you very much. Thank you very much. I did that in an hour 12, so I was 5 minutes over, but I'm happy to take a couple questions if you'd like me to answer some. Or we could just go drink.
Any regrets?
Yes, let's go drink and talk about that. You know what? I'll say one thing. It's scary as hell. We made tons of mistakes, but we have great partners, and no one blames anyone. No one criticizes why we made the decisions we made. Some were good, some were bad. At the end of the day, I mean, like, you know, it's great to have the reward, but the reward it was nice to make a little bit of money, but it wasn't about the money. It was about having the resources to expand what we were doing and to build the practice. We started the practice with zero capitalization, not 1 cent. And, you know, for 12 years, we've reinvested every single cent back into the company. And, you know, when you make mistakes, and I can think of lots of things we could have done better, but if you're with good people and you have a good time, none of it really matters. Oh, that was too easy. You can't let me off the hook that easily. Donna, come on. Good. Are we totally done? Wow. All right. Thank you very much.